All right, let's dive into this repo. So, the name is Fablize, and it's a Claude Code plugin. The description says it makes Opus behave like Fable, with completion, evidence, and verification enforced as a procedure. What problem is this solving?
The core problem is ensuring that models like Opus complete tasks thoroughly, with verifiable evidence, similar to Fable. The repo's README explains that Fable 5 and Opus 4.8 were compared, and while they were tied on closed tasks, Opus lacked the procedural depth in open-ended work. Fablize injects those procedures to make Opus follow through on tasks with verification steps.
Got it, so it's not about improving the model's capabilities, but enforcing a workflow. How does the repo structure address that?
The repo is organized around several key components. The Claude plugin directory holds marketplace and plugin metadata. The setup directory includes scripts for installation and configuration. The scripts directory contains the main logic, like goals.py, which manages task decomposition and verification, and gatestop.py, which blocks incomplete work. The hooks directory has shell and Python scripts that act as guards or routers to enforce procedures.
Interesting. Let's look at goals.py. What's its role in this workflow?
Goals.py is the heart of task decomposition. It breaks down a task into sequential stories, each with objectives. Each story must be checkpointed with evidence, and the final story requires verification through a command and result. The ledger.json file logs these checkpoints, ensuring persistence across sessions. This enforces the verification gate, preventing completion without proof.
So the verification gate is a key part of this. How does that work technically?
The verification gate is implemented in script/gate/verifystate.py, but the logic is referenced in goals.py. When a story is marked as complete, it must have non-empty evidence. For the final story, it also requires a verify CMD and verify evidence. This ensures that the model doesn't just claim completion, but actually runs a verification step, like executing a generated script or checking output against expected results.
That makes sense. What about the early stop prevention mentioned in the README? How is that implemented?
Early stop prevention is handled by hook/gatestop.py. This script checks the ledger to see if a task has changed files without successful verification. If so, it blocks completion and issues a warning. It respects a maximum number of blocks to avoid excessive interruption, and there's an env-gated holdout for testing purposes, which can suppress the gate for certain sessions.
Nice. That's a good example of a technical detail. What about the per task router mentioned in the README?
The per task router is defined in hooks/hooks.json and implemented in hooks/router.sh. It injects specific verified disciplines based on the task. For example, if the task involves rendering an artifact, the router triggers verification grounding. This ensures that the right procedures are applied dynamically without hard-coding them into the model's prompts.
I see. So the router is a kind of dynamic gatekeeper. What about the limitations mentioned in the README? Any caveats?
Yes, the main caveat is that Fablize doesn't enhance the model's inherent capabilities. It can't improve open-ended creativity or self-driven discovery. It also relies on specific injection experiments to verify procedures, which means it's effective only within the tested scenarios. The early stop hook might misfire on declarative offers, like, "I'll write the report if you want," and phrasing as a question can help avoid that.
All right, let's take a look at a specific file. The setup.sh script seems important. What does it do?
Setup.sh is the always-on setup script. It injects the operating block into Claude.md, making the procedures resident in context. It handles star decisions, detecting the user's language from past sessions and prompting them to star the repo if they choose. It also sets up the state directory and manages the star.json marker to ensure the star request is only shown once.
That's a lot of functionality in one script. How does it handle language detection?
The detect lang function in setup.sh uses Python to analyze past user transcripts. It counts Hangul, Kana, and Latin letters in user input to guess the primary language. This is used to determine the language for the star prompt, ensuring it's shown in the user's preferred language. It's a heuristic, but effective for the use case.
Impressive. So the script is both a setup and a language-aware installer. What about the tests in the repo?
The tests directory includes testgate.py, testgaterobustness.py, and others. They test the gate logic, robustness, recovery, and shadow behaviors. For example, testgaterobustness.py checks if the gate correctly blocks incomplete tasks and handles edge cases. These tests ensure that the procedures are enforced as intended without false positives or negatives.
That's thorough. What about the hooks in the hooks directory? Are they all active?
The hooks directory contains several active guards. GatePostTool.py and GatePrompt.py are part of the verification workflow, while GateStop.py prevents early completion. The Router.sh script dynamically routes tasks to the appropriate procedures. Each hook is designed to work with the others, creating a layered defense against incomplete or unverified work.
So the hooks work together to enforce multiple layers of verification. What's the overall impact of this repo?
The impact is that it makes Opus behave more like Fable by enforcing verified procedures. It ensures that tasks are completed with evidence, reducing the risk of unverified conclusions. This is particularly useful in scenarios where reliability and traceability are crucial, like code generation or logical problem solving. Exactly.
Who should really care about this repo?
Developers and engineers who need reliable, verifiable task completion from large language models, especially in environments where evidence and systematic investigation are critical.